Hello, my name is Daniela Mendez, and I'm a student at Central Washington University. I have been working on this research project since fall 2021 with the help of Dr. Gabrielle Stryker in her laboratory. This research project is about the prevalence of Rickettsia in ticks collected near I-90 in Upper Kittitas County. The goal of this research was to collect DNA samples from ticks, determine if they had Rickettsia, which species of Rickettsia, and if they were pathogenic and presented a health hazard to Kittitas County. In Washington, there is a prevalence of tick-borne diseases, which we can observe on table number 1. Such diseases are babesiosis, tick-borne relapsing fever, Lyme disease, tularemia, spotted fever, rickettsioses, and tick paralysis. All of these diseases are being caused by the respective pathogens that we see over here. We can also see the incidence in 2018 and incidence in 2019. All these diseases are being transmitted by ticks, meaning that these ticks qualified as vectors. Ticks can become infected with Rickettsia if they feed of infected mammals or if they pass it to their offspring. Dermacentor is the most common tick in eastern Washington that is responsible for the transmission of Rocky Mountain spotted fever. To begin my research project, I started by collecting ticks, as it's seen in figure 1, on the east side and west side of Washington. Unfortunately, I was unsuccessful, but the I-90 Snoqualmie passed this project, and Dr. Ernest and Dr. Beck gave me tick donations. After these donations were given to me, I started mincing the ticks, which you can see on table number 2. All the ticks that I worked with and positive or negative signs representing whether they tested positive or negative for the following primers. After mincing these ticks, unfortunately I lost tick number 20, but I continued working with the rest of the ticks. I used the Simon Research Quick DNA Tissue Insect Mini Prep Kit in order to extract DNA from these ticks. I wanted to make sure that I was successful in this DNA extraction, so I developed a polymerase chain reaction with the primer called HCO-LCO, which recognizes the cytochrome oxidase gene at 741 base pair. After this DNA extraction was done, I added a positive sign to those ticks that I was able to extract DNA from. And as you see in tick number 10, there's a negative sign, meaning that the DNA extraction was not successful. After the DNA extraction, I continued my project by utilizing the primer RR190.70 for another PCR. This primer recognizes the 190 kilodaltons antigen gene in ticks. This primer is also useful for the detection of presence of Rickettsia in ticks. As you can see in figure number 3, we also used a control sample that came from Rayanne's previous tick research project. As you can also see, the band that we are wanting to see is located at 532 base pair. You can also see the rest of my ticks, and you can say that 2, 3, 4, 6, 7, 9, 11, 12, and 13 through 21 were positive for Rickettsia. After I was done with the RR190.70 primer, I continued with using another primer called the GLTA, which is demonstrated in figure number 4 at 341 base pair. This primer allows us to recognize the citrate synthase protein gene of Rickettsia. This primer allows us to obtain genes that are useful to perform sequencing and then determine the species of Rickettsia. As you can see from the agarose gel product, all of my ticks tested positive for the GLTA primer except for tick 7 and tick 21. Continuing my research, I utilized the primer OMPA. This primer recognizes the outer membrane protein A gene at 444 base pair. From this figure, we can say that most of my ticks had the band at that band size except for tick 9 and 21. You can also see multiple bands besides the 444 base pair, which is due to the non-specific binding that the OMPA primer had. This means that the primer was recognizing other genes besides the OMPA gene. After obtaining my results, I analyzed the gels and what these figures meant in the context of my research. We can conclude that 80% of my ticks tested positive for Rickettsia, and 87.5% of those ticks that tested positive for Rickettsia also tested positive for the GLTA primer. And we can also say that 87.5% of the ticks that tested positive for Rickettsia also tested positive for the OMPA primer. It is important to mention that there are some inconsistencies, such as missing bands on ticks 7, 9, and 21, which can be due to mixing error during the production of the PCR, or some contamination, or even pipetting error. Some solutions for these would be to redo the PCR or the gel while being careful while pipetting. This data demonstrates that Rickettsia ticks are predominant in Kittitas County, but the existence of pathogens in these ticks are still yet to be determined. It is important to continue the collection of data in order to expand the sample pool. As future research, we have plans of sequencing DNA with already cut PCR bands. We will also be identifying juvenile ticks and take the samples for other tick-borne diseases. I would like to thank my research mentor, Dr. Gabrielle Stryker. Also wish to thank Dr. Christine Ernest and Dr. Daniel Beck donations. I'm really thankful because of their tick donations. Without their help, I wouldn't have been able to have samples to work with. I would also like to thank Rayanne Techman for her help, and also the College of the Sciences at Central Washington University for the help and support to complete this research project. Thank you so much.